Okay, here we are in assignment 1 in Moodle, and I'll remind you that there are videos, 3 videos, one on algebra, one on trig, and one on units conversion. They're general videos, and you can look at those, but this particular lecture is geared specifically for assignment 1. So you'll see, in the beginning, you'll see set of instructions about the assignments, since this is your first online assignment. And then there are a couple questions about the syllabus, so you just need to read the syllabus and answer those. And then there's a series of relatively simple algebra questions. So do those, and then there's a series of relatively simple trig questions that I think you'll... And so why don't we start with 17 as being maybe a little bit harder than others. So I'm going to start here. Actually, now that I looked at it, it's not a very difficult problem, but it's a chance for me to illustrate for you the kind of problem-solving formatting I want you to learn. So here's the problem. I look at it. I see I want angle B, and I'm given A and B. And so B is the opposite side to A is the adjacent side, B is the opposite side to angle B, A is the adjacent side, so I know I want to use tan. So I start solving the problem by writing down the equation that I'm going to use. Then I take the general equation, and this is the way I want you, the formatting that you should use when you're solving problems, when you're writing out the entire solution. So there's the general equation. Now we see that the angle theta we're looking for in this problem is B, and the opposite side is the side B, and the adjacent side is the side A. And so to get B, I need to take the inverse tan of both sides of the equation. So you know the inverse tan or the arctan, we can write it this way, or you can write it as arctan. And then I put the numbers in. So notice I do symbolic algebra before I put the numbers in. This is, I want you to learn to do problems this way. So B equals the inverse tan, there are the numbers. Notice I put in the units. Notice the units cancel. And so when I take the inverse tan of 4.9 over 6.4, I get 37.438 degrees. But since the data we're given is only 2 significant figures, the answer should be only 2 significant figures. So let's check the answer. Okay, there you have it. The answer checked out, 2 significant figures. We get the green check mark. Let's go to the next one. So if you're here and you haven't done this one, read it over. Pause the video and read it over and try and do it. Rather than just sit here and watch me do it, you try it, and if you can do it, then you can see what I did, and you can fast forward the video if you got it right. Okay, so following what we did in 17, we can get angle B by taking the inverse tan of the opposite over the adjacent. And then once we have angle B, if we use the equation sine theta equals opposite over hypotenuse, this side H is the opposite side of this right triangle, where A is the hypotenuse. So notice we're using this right triangle to get B here, and then we're using this right triangle, which has the same common angle B, only in this case A is the hypotenuse and H is the opposite side. So the sine of theta equals opposite over hypotenuse. The opposite side from the angle A, that's what we want. So opposite equals hypotenuse doing the algebra. opposite equals hypotenuse times sine. So the opposite side here is the h, the hypotenuse is the a, and we take the sine of b. So let's put the numbers in. H is going to be 7.6, that's a centimeters, times the sine of this angle. And this angle is the inverse tan of 5.6 centimeters over 7.6 centimeters. And so we do the calculation in one step. I didn't even bother to find angle B. And I get this result. But I only want to report two significant figures. So let me put the answer in and check it. Okay, there it is. Well, actually, you see the answer? I got logged out, so it came back with different numbers. So when I used these new numbers, the 5 and the 7.6, I redid the calculation, same equation. I got 4.2 centimeters, and it's correct. Okay, try 19. Read it over and see if you can do it, and then see what you get compared to what I get. Okay, very similar to what we did last time, only this time we're asked to find x. So x is part of this triangle. So I want to find angle A. So we start with the big triangle. And if we use the big triangle, then B is adjacent to A. And A is not the hypotenuse of this triangle. This is the hypotenuse. This is the opposite side. So it's a tangent function. So the angle A is the inverse tan of the opposite side, A, over the adjacent side, B. So that will get us this angle A. And then, since X in this smaller triangle, X is the adjacent side, so I use the cosine equals adjacent over hypotenuse. So the adjacent side is equal to the hypotenuse times the cosine of the angle. The adjacent side is the x that we want. The hypotenuse, B, is the hypotenuse of this triangle. And so we take the cosine of that angle, which is this, the angle A. So now I put the numbers in. So B is 5.0 centimeters. I should have centimeters written there. Cosine of the angle, which is the tangent of A over B. I put the centimeters, I cancel them. Remember, there's a centimeters here. And so when I calculate it, that's what I get. And so 2.7 centimeters should be the answer. Let me check it. Okay, good. We got it. All right, this is the 2.7 centimeters. So we can move on to the next one. So the next one, number 20, is very similar to the one we just did, only you're finding y, so I think you know the procedure. I'm not going to do this one out. I'm going to skip ahead to number 21, which is a units conversion problem. So let's do a units conversion problem together so you can see the formatting and how it works. So go to 21 and see if you can do it. And remember, you're writing everything out, because if when you do the Moodle problems, you don't have to do the work out. But on a quiz, sometimes I may ask you to actually write out all the steps. So take a piece of paper, write out all the steps and get the answer, and then come back and check to see what I did. So the method for doing units conversion is to use conversion factors, which are ratios, and cancel all the units you don't want to get to the units you want. And so we start with 62.54 meters, and the closest thing we have to that is centimeters. So we want to change the centimeters, the meters to centimeters. So I write centimeters over meters, and I cross the meters out. But we want yards, not centimeters, but we have centimeters to inches, so I write inches over centimeters, and then the centimeters divided by centimeters will cancel. And then the final thing, oops, it went off the screen. Well, I lost it. But the final thing would be yards over inches, and then the inches would cancel, and you'll be left with yards. So what you're going to write in is you're going to multiply this number by a factor which is 1, right? If you multiply by 1, you don't change the number. So 100 centimeters is equal to 1 meter. So that's multiplying by 1. And the meters cancel. And then there's 2.540 centimeters in 1 inch. And so the centimeters cancel, and we're left with inches. And then the last thing is 36 inches is 1 yard exactly. And so the inches cancel, and we're left with yards. So you take the 6 point. This way you're not guessing whether you need to multiply or divide by the number. So always write the units out and cancel the units. So the calculation is going to be 62.54 times 100 divided by 2.540 and divided again by 36. And that will give us the answer. Let's see what that is. Okay, so when I do that calculation out, if I didn't make a mistake, I got 68.39457 yards. But I have 4 significant figures everywhere. So I'm going to keep 4 significant figures. So the 39 stays 39, 68.39 yards. Okay, now a couple things to notice. One is, you say, but this 1 yard is 36 centimeters. That's only 1 significant figure, or 2 significant. No, 1 yard is 36 inches, exactly. These are not rounded. These are exact numbers. And the 100 centimeters in 1 meter is an exact number. It's not 99.99. It's 100 with an infinite number of digits. So the 1 here isn't 1 significant figure. Now the 2.540, if you had 2.54 and you didn't have the 0, that factor isn't an exact number. And if you run this out, you'll get more numbers. So you have to be careful when you're doing the significant figure, knowing that something like 100 centimeters in 1 meter is an exact number and not something that has only 1 significant figure. And so that's the first thing. And so you need to round. Everything in here is 4 significant figures. And so the answer should be 4 significant figures. And we include the units. Okay, so let's go ahead and check that and make sure we didn't make a mistake. Oops, I just noticed that it's asking for the answer in scientific notation with the right significant figures in units. So the 68.35, if we put that into scientific notation using this formatting, we would have 6.839 E1. And remember, the E1 means 6.839 times 10 times 10, or times 10 to the 1. So let's try it with that formatting. So notice I put in the 6.839E1 and I got a funny check mark. That means it's right, but I forgot the units, so I have to go back and put the units in. So let me check it again. Okay, that worked. Let me check one more thing. Okay, I just tried it again without using scientific notation, and it does take it. So Moodle doesn't really force you to use scientific notation, but I do want you to practice it. Truthfully, a number like 68.39, in most circumstances, since it's e to the 1 or times 10, we would just leave it in this format. But we are practicing in these exercises using scientific notation, so if it asks you to use it, please use it. Okay, let's do one more units conversion. Do question 23, a volume conversion. See if you can get the answer, and then come back and see what I did. Let me just interrupt with one comment here. You might say, wait a minute, why don't we just go on the internet or go someplace and find the conversion factor for meters to yards and just use it and save us all that work? Yes, if you can do that, that's fine. But right now, we're just practicing units conversion. So the same way, you could go on the internet and try to find volume conversion from grams per centimeter to kilograms per meter. But supposing we didn't have access to the internet, or supposing all the information we had was what's given in problem 23. So that's for purposes of practice, and in some situations you have limited knowledge of what you can do. So anyway, back to problem 23, go do it, and then come back and see what I did. Okay, in case you're stuck, let me just get you started. Start with the density equation. Density is the ratio of mass to volume. Do the algebra, solve for volume, that's what we're looking for. And so we see that to get the volume, we need to divide the mass by the density. We have the mass and the density, but the density's in the wrong units. And in order to get centimeters cubed, there should be a cube there, we need the density in grams per cubic centimeter, and the grams will cancel, and the volume will end up in cubic centimeters. So the next step is to change the density from kilograms per meter to grams per cubic centimeter, put it here, and we'll get our answer. Go ahead, continue. Okay, in case you're stuck again, remember the method for doing units conversion? We have kilograms per meter cubed, so we need to change the kilograms to grams. So that factor needs to be grams over kilograms, and then the kilograms will cancel, leaving us with grams. Then we have to change the meters cubed to centimeters cubed. So if we put in a conversion factor of meters cubed to centimeters cubed, we don't have to guess whether to multiply or divide. We just cancel the units of meters cubed, and you see what you'll be left with is grams per centimeter cubed. So put those numbers in and finish. Okay, there it is, but it's easy to make a mistake here. So, yeah, we all know, or you should know by now, that 1,000 grams in a kilogram, right? The kilo always means 1,000. Those are the prefixes you're going to learn this week. So 1,000 grams in a kilogram, so that's what I put in there. The kilograms cancel. But we know that there's 1 meter is 100 centimeters, right? The word centi means 100. But when you cube the 1 meter, you still get 1 meter cubed. But when you cube the 100 centimeters, you get 100 times 100 times 100 cubed. You get 1,000,000 or 10 to the 6th. So when you do this out, you end up with 1.738 grams per centimeter cubed. The grams cancel. You get this result, but you have to round it to what? 4 significant figures, because everything in the problem is 4 significant figures. So there you go. Let's check it. Okay, we're good. Notice the formatting. Well, you can't actually see it, but there's centimeters cubed is there. It's just not showing. So I put it in scientific notation. I've got the units. It's correct. If you had put in 18.8, which would be the wrong number of significant digits, centimeters cubed, Moodle will accept it. But Moodle's not smart enough to know whether you're doing it exactly right. So you could be... Anyway, this is the correct format. Notice 3 significant figures, only 1 digit before the decimal at scientific notation, and the correct units. Of course, under normal circumstances, if you wrote 18.80 centimeters cubed, I'd be perfectly happy with that. But remember, we're practicing scientific notation. And of course, always correct significant figures are expected. Okay, we'll move on to the next set of exercises. Okay, here we are, problem 24. You do need to pay very careful attention to the instruction guidelines. If you use a comma or a dash or the word and, or you put something in the wrong format, it won't read it properly, and it'll mark it wrong, or it won't even realize that there's something in the box, and it'll say you haven't completed. Also, notice you're only seeing 3 columns here, so in your display make sure you see all 5 columns. I'll show you that in a minute. So let me just randomly run through a few of these things. Notice, let's go down to this one. So that's, when we move here, we're into the thousands, we're in the millions, so this is 47,800,000,000. And if we move the decimal point 3 places, 6 places, 9 places, 10 places, you're going to get that this is 4.78 times 10 to the 10th. But, and there are 3 significant figures because we don't consider the zeros, the place holding 0 significant figures, and that shows up here. But when we use the prefix, we want to do it in billions. So thousands, millions, billions. So when we use the prefix, it would be 47.8 billion, or 47.8 giga. That's the thing. So if it were, say, like a computer speed, it would be gigahertz. So that's how that prefix item works. All right, let's scroll. Well, let me pause and fix that. So coming down here to 93 billionths, the easiest way to write that, not that it's asked for, is 93 over a billion, right? And so that's 10 to the minus 9, so it's 93 times 10 to the minus 9. So if we want to go into scientific notation, it's going to be 9.3 times 10 to the minus 8. Right? Because if you make this smaller, you got to make this bigger, and making this bigger, since it's a negative exponent, means going to a lower number. And the tricky part is, how do you write this in regular notation? So 0.000. Remember, space is not common. 0, 0, 0. And then 0, 93. And how do I know that? because if I move the decimal point, whoops, I lost it. Sorry. If I move the decimal point 3, 6, 9 places, I'll have 10 to the minus 9, and that's 93 billionths. And billionths is nano. And so what we would get is 93 nano, whatever it was, nanometers or nanoseconds, little n. Okay? All right, whoops, yeah, do this one here. Do that one. Okay, I hope you paused and did it, not just listening to me. So you move the decimal point 1, 2, 3 places, and you get 628 billionths, right? That's 10 to the minus 3, 10 to the minus 6, 10 to the minus 9. So 600, no and though, 628 billionths. That would be 628 nano, whatever the units are. And to go into 3 significant figures and to go into scientific notation, you have to move the decimal. Well, 2 ways to think about it. It could be 628 times 10 to the minus 9, and that would be 6.28 times 10 to the minus 7. Or if you go back to the original number and you move the decimal point 3, 6, 7 places to get to the 6.28. So it's 6.28 times 10 to the minus 7. Before we move on, I just wanted to show you, because we couldn't see it, these other 2 columns, the significant figure column and the prefix notation column. So there are 1, 2, 3, 4, 5 columns, and make sure you see all of those. Okay, let's move on. And 25 is a question where you practice your prefixes. Remember, they're all on the equation sheet and you can look them up online. More practice on prefixes and some more algebra, general algebraic solution. We see we do a lot of that in physics, both semesters. Problems that are getting a little bit harder algebra-wise. Should we do one of these? All right, let's do number 30. Just remember, the rules of algebra are do the same thing to both sides. So here, I leave the negative x squared alone. I subtract 4y squared from both sides. Subtract from both sides. This makes it 0 here, brings it here. And then I do 2 things here. I reverse the equation. I bring the x over this side to the left and the other to the right. And then I multiply by a -1, right? I multiply through the equation by a -1. That makes the x squared positive. That makes this positive, and it makes this negative. And here we are. And that gives us, for my screen, g, right? Of course, you take the square root of both sides, and you get this. But then you can see there's a common factor of 4 here. So if we subtract, if we take the 4 out, then we would be left with y squared minus 3z squared times 4. All of that is still under the square root sign, but wouldn't it make sense to take the square root of this? And then we would get 2y squared with the 2 outside of the square root brackets. So this one's correct, this one's correct, this one's correct, and I think that's it. Unless there's another one hidden in there, let me look. Oops, I got one of them wrong. I wasn't looking carefully. I changed I mixed up the y and the z, right? It should be f, not g. I said it was g. So this is the correct one. Actually, if you wanted to be technical about it, there's another mistake in this problem, is that when you take the square root, you should get a plus or minus sign. So anyway, these are correct, but strictly speaking, they should have a plus and minus sign, because when you take the square root, you get plus or minus the square root of the quantity you take the square of. Okay, let's move on. And another trig problem. And this we have general solutions, right? When I did those earlier problems, I did these as well. So this is what, 32? Yeah, let's do 32. Why not? And it wants us to pick out all the correct expressions out of that list of expressions. So take a look at what we're asked for. We're asked for little m, big M, little n, big N, and h. So 1, 2, 3, 4, 5 different things. And so let's start with the little m. So remembering back to what we did back in a previous problem, like 17, I think it was, angle C with A and with B and C, we can get this angle, right? So the tangent of any angle is the opposite over the adjacent. So the tangent of C is C over B, and so the angle C would be the inverse tangent of C over B. Similarly on the other side, right, we're using the big triangle where A is the hypotenuse. This side B is opposite B and C is adjacent, so by the same method, angle B is equal to the inverse tangent of B over C. Now side M is adjacent to C. So we do know B, and so B, if we go to this triangle, B is the hypotenuse. So we want to use cosine to get M, right? The cosine of C will be the adjacent side M over the hypotenuse B. Let me write that down. So the cosine of any angle is the adjacent, not this A, just adjacent over hypotenuse. And so the cosine of angle C will be the adjacent M over the hypotenuse B. And so we solve for M and we get M equals B cosine C. But C, the angle C, is the inverse tangent of B over C. And so M would be B times the cosine of the inverse tangent of C over B. And can we find that choice? Right down here, item G. Okay, what should we do next? We'll do little n, because little n is adjacent to B, and we know how to get angle B. And for this triangle, C is the hypotenuse. So by the same argument we used over here, little n will be the hypotenuse C times the angle B, cosine tan minus 1 B over C. And we do have that selection here. To move forward, there's another item here that's worth noticing, because these three right triangles, the two smaller triangles, are included in the larger triangle. So watch this. Angle B, whoops, angle B plus angle C have to be 90. right? This angle plus this angle is part of the big triangle. So those two angles have to be 90 because the whole thing, that's a right triangle, has to be 180. Remember that? But similarly, B and N have to be equal to 90. So if B and C are equal to 90 and B and N are equal to 90, then by that argument, C equals N. And by a similar argument, C and B equals 90, and C and M have to equal 90. So B and M are equal. Let me write that down for you. Make sure you see that. So in case you've forgotten, all the angles in any triangle have to add to 180. In a right triangle, one's 90, so the other two angles have to be 90. So B plus C has to equal 90. And this is a right triangle, so B plus N has to be 90. So B plus C has to be equal to B plus N. If you subtract B from both sides, you get that C equals N. And doing the same thing on the other side, you get that B equals M. Okay? So we'll use that, and we can finish the problem. That leads to these two selections. So M is equal to B, and B is inverse tan B over C. So M is also inverse tan B over C. And this one's a little tricky. It says N is the sine of C over A. So you need to take a look at that. The angle C has the side C opposite it, and A is the hypotenuse. So the inverse, the sine inverse of the opposite over the hypotenuse does give the angle C. And since C is equal to N, then this choice is also correct. And now we have to look for H. So we look at H, and it says C sine. So how do we do that? Well, let's look at this element. Let's just see. The tangent of B, the inverse tangent of B over C is angle B. And then we have the sine. So the sine of B equals the opposite H over the hypotenuse C. So the sine of B equals H over C. And so H would be C times the sine of B. And so that's correct also. I'll write that out for you just so make sure you see it. So once again, sine of any angle theta is the opposite over the hypotenuse. So the opposite side is going to be equal to the hypotenuse times the sine. And if we use this triangle, the opposite side from B is H, little h, so that's the opposite side. The hypotenuse is C of the angle B. So the sine of B, C times the sine of B would be H. And B, from here, is the inverse tan of B over C. And so we see that that selection is also correct. Okay, checks out. Good. We're done. Oh, one more thing. I'm going to give you a table of contents at the end. So if you want to look for specific problems, you'll be able to find them without having to fumble through the video or scroll through the whole video. So here's the list of all the problems I did out completely. There may be some brief comments about others, but here's the list of all the problems I did out completely and the approximate times at which they appear in the video, so that if you just want to look for a specific problem, whether I did it or not and where I did it, you can find it very quickly here.